afternoon, everybody. This is Henry from A-STEM Tutoring, once again attempting to serve as your wise old sensei. No, I'm not a construction worker, but this worker here working hard illustrates something important about physics that I'd like to discuss today. It's been a little while since I've posted a lesson. My apologies. Thanks for waiting for this next lesson. I really appreciate anyone who views this. All right, so suppose this worker is using some mechanical advantage granted by this ramp to push this large, heavy object, a safe, up to a certain height instead of lifting it straight up. So something that students may get confused about is, well, what fraction of the actual weight of the safe does the construction worker have to push in order to move it upwards? Is it mg sine theta, mg cosine theta, mg tan theta? So many trig ratios, it gets confusing, right? Well, let's first model this with a diagram. So there's the mass m. The parallel component of its weight is going down the ramp, and that's what the worker has to push against. So what fraction of the actual weight, mg, mass times gravity, acceleration due to gravity, is going parallel to the slope of the ramp? I realize it may get confusing sometimes. Do I use sine, cosine, or tangent of theta? All that kind of thing. Well, let's do a simple thought experiment. Assume for the moment there is no friction between the object and the ramp. And let's take an extreme case where the angle theta is 0, perfectly flat ground. In order to get the mass moving, it actually takes 0 force because all the weight is perpendicular to the direction you want to move the mass. So when the angle is 0, the force exerted parallel to the incline must also be 0. Now let's look at another extreme. What if we increase the angle to 90 degrees, straight up? Well, at that point, the weight parallel to the incline, the surface of the incline, is going straight down. So it's the full weight, mg. And then the question becomes, what trig ratio, what trigonometric function equals 0 when the angle is 0 and reaches a maximum when the angle is 90 degrees? Well, if you remember trigonometry, that must be sine theta, because sine of 0 is 0. Sine of 90 degrees is 1. You'd be lifting the full weight of the heavy object. So to find the force parallel to the incline, that is simply mg sine theta. This is how much force a construction worker has to push against in order to move that mass up the ramp. A smaller angle, a smaller value of theta, a shallower angle, the sine is less. That means the weight that the worker must push against in order to move this mass is less. It makes it easier. It gives the worker a mechanical advantage. The trade-off is that in order to elevate by a certain height, the worker must push the mass through a much longer distance. So the total amount of work done is still the same because there's still the same amount of change in the potential energy of the mass. But the force required at any given moment is far lower if the angle theta is a smaller angle. So again, remember, at an angle of 0, it's flat, so there's no weight parallel to the incline. When the angle is 90 degrees straight up, you have to push against the full weight of the heavy object. And sine theta matches that specification. So the force parallel to the incline for an object on an inclined plane must equal the weight, mg, times the sine of the angle theta that the incline makes with the level ground. That concludes today's short physics lesson. I hope you found this useful. If you'd like to learn more, I am available for hire as a private tutor. My information is in red at the top of the whiteboard there. The first 1-hour lesson is free for all new students. Try before you buy. No financial risk, just to try me out. If you don't like the lesson, you don't want to continue, that's okay. We still part as friends. And as a thank you for watching all the way to the end of today's lesson, if you mention the code FREEBOOK when you contact me at our first meeting, I will give you a free copy of my book, Smart Suggestions for Student Success. I wrote this book in an effort to help students, and especially high school and college students, succeed in school, work, and in life. Thanks for watching. Have a good day.